Mario didn't show his work and he got a 0.
Oh no, Mario. You must show your work. It's important for you and for Mr. Eng to see. No, I think he's actually showing his work.
Yay, good job, Mario.
And remember to always show your work.
The question is, which factor does not belong? So we need to solve this math. So they have 4 terms. So we need to put it in the D box. Like this. So I put 3x cubed plus 5x squared negative 27x and negative 45. And then I put 3x in the top, and in the left side I put x squared because 3x times x squared is 3x cubed. And then I put 5 here because 5 times x squared is 5x squared. And then I put negative 9 in the left because negative 9 times 5 is negative 45, and negative 9 times 3x is negative 27x. So we have 3x plus 5 times x squared negative 9. Then we put 0x here to solve this math. So we got negative 3 and 3 because negative 3 times 3 is negative 9 and negative 3 plus 3 is 0. So we have 3x plus 5 times x negative 3 and times x plus 3. So look at the answer. They have x plus 3 right here. So it's belong 3x plus 5 right here and 3x minus negative 5 is not here. So this one is not belong. Question number 2 is factor. So we have 3 terms. So we can use the X box. A is 9, B is 30, and C is 25. We have A times C and B in here. A times C. A times C is 225. And B is 30. So we get 15 in the both side. Because 15 times 15 is 225 and 15 plus 15 is 30. Then we put it in the box. Right here is 9x squared and 25. And then we put a 15 here. 15x is also. And then I put the 3x here and 3x in the left because 3x times 3x is 9x squared. And I put 5 in here because 5 times 3x is 15x. And this one is also. So we got 3x plus 5 times 3x plus 5. So this is our answer. Next question is, the following expressions are examples of either the sum or difference of cubes, which is not an example of the sum of cubes or the difference of cubes. So we already have the sum of cubes is a plus b times a squared minus a times b plus b squared, and the difference of cubes is a negative minus a minus b times a squared plus a times b plus b squared. So look at this one. This is sum of cube right here. So a is u, b is 3. So we have, it's here. A squared is u squared. Negative a times b is negative u times 3 or 3 times u. It's the same. And b squared is 9 because 3 squared is 9. So this one is correct. This one, the second one is right here. Difference of cubes. A is d, b is 6, and then a squared is d squared, and next is plus, but right here is negative, it's minus a times b. So this one is not an example of the sum of cube or the difference of cube. So this is the answer. The next one is can 1 2 3. So we can start right here. It's 3 and 1 because 1 plus 3 is 4. And then right here is 2. And right here is 3. I just guess. So 3 minus 2 is 1. And the last one is 1. So right here maybe 1, and right here is 2, and then this one is 2, and this one is 3.
Starting from 5, which is this one, the printer didn't do it too well. We have x to the 4th plus 2x to the 2x squared minus 24. So for this situation, I personally just like to take this straight into cross and box. So what we'll do is we'll just put negative 24 up here and 2 here, and then we'll put negative 12 here, and wait, we won't. Sorry, that's a tricky one. So it needs to add to 2 and multiply to negative 24. I almost made a mistake there, but what you would do is you would take 6 and negative 4 instead. Ooh, and then that is 6 minus 4 is 2. 6 times negative 4 is 24. So now what we'll do is we'll put that into a box, although personally I like to skip this part since it's faster. But we'll put x to the 4th here and negative 24 here, and then we will put 6x here. No, we'll put 6x squared, sorry, and then we'll put negative 4x squared here, and then we will pop 6 and negative 4, which will equal 24, and x squared and x squared. Now we have our factored form, which is x, or our half factored form, which is x squared minus 4 and x squared plus 6. Now our goal is to factor and solve. We want to do both of those things. So we're going to fully factor this, and then we're going to solve for all of its zeros. So now we can make two smaller x's, or I personally like to make them smaller, and then we do 0 and 0, since the 0 is what's missing in both of these, and then we'll have negative 4 in one and 6 in the other. Now for this situation, negative 4, because it's a negative, I know that it cannot be multiplied into, and 6 is not a square of anything, so it can't be factored out, which means both of these are prime factors. So this means we're going to have to take this into the oh god, I didn't so these two are both prime factors, as we found here and here. So what we need to do is we need to basically figure out what the squared zeros are, and that means that x squared equals 4 and x squared equals negative 6. And I always figure that when it's just the first term is 1, then it's the exact opposite of the second term in that. So negative 4 would be 4, and positive 6 would be negative 6. Ugh. Okay, so now we just put a square root on each of these. We find that x equals, and the square root of 4 is 2, and then, or actually it's plus or minus 2 because it's a square root, and then x equals plus or minus, and then we find it's 2 and 3, so it'll be I. 2 is not a square, so it'll be I and 6. And that means that we have actually all of our, this is solved. So x equals plus or minus 2, comma, plus or minus I rad 6. And that is our answer.
For number 6, we can see that there is a GCF, which is x, because 3 times 5 x's plus 10 times 3 x's plus 7 times 1x, and they all have 1x in common, or x to the power of 1, so we take that out, and we're left with 3x to the 4th plus 10x squared plus 7. Then here we can see that the half of 4 is 2, which means we can use xbox. 7 times 3 is 21, and our b value is 10. Two numbers that multiply to be positive 21 and add up to be 10 are 7 and 3. Then we put in our values in the x box, 3x to the 4th, and the constant, which is 7, and then 7, in this case it will be x squared, and 3x squared. The GCF of 3x to the 4th and 3x squared is 3x squared. And then we're left with x squared. A number that multiplies with x squared that equals to 7x squared is 7. And the GCF for 3x squared and 7 is 1. the next thing we have to do is write these out as factors. So, but we shouldn't forget that there was an x here, so this goes here. X times 3x squared plus 7 times the quantity of x squared plus 1. This would be our answer for factoring, but to get our answer for solving, we have to set each factor equal to 0. So x equals 0, and 3x squared plus 7 equals 0, and x squared plus 1 equals 0. This would be already simplified. To find the solution for x squared plus 1, we subtract 1 on both sides, and we get x squared equals -1. But we have to get rid of the squared, so we square root both sides. X equals the square root of -1 is basically I, so plus or minus I. To solve for this one, we first subtract 7 on both sides. So this becomes 3x squared equals -7. And then we have to get rid of the 3 here, so we have to divide 3 on both sides. This cancels out, so x squared equals -7 over 3. Then we do the same thing with this one. We square root both sides. The square root of x squared is x. And we can rewrite this expression as the square root of -7 over the square root of 3. What we have to do is rationalize this expression, which means we multiply it by 1. But by 1 we mean the square root of 3 over the square root of 3. And so the square root of -7 times the square root of 3 is the square root of -21. And the plus or minus sign goes here. And the square root of 3 times the square root of 3 is equal to the square root of 9. And the square root of 9 is 3. So 3 will go here. And then we can still simplify the square root of -21, because when we expand -21, it's -1 times 21. And we know that the square root of -1 is I. So the final answer would be x equals plus or minus I times the square root of 21 over 3. For f of x, we can use factor by grouping. So it will look something like this. 3x cubed plus 5x squared plus the quantity of -27x minus 45. And we take the GCF of this factor. When we expand it, it's 3 times 3x's plus 5 times 2x's. And we can see that they both have 2x's. And when we take that out, we're left with x squared times the quantity of 3x plus 5. We do the same for the second one. We can also see that they also have a GCF. When we expand it, it can be -9 times 3 times x minus -45 can be -9 times 5. And now we know that both of them have -9 in common, so we take that out as well. So when we write it, it becomes -9 times 3x plus 5, because we took out the negative as well. So we're left with just +5. And we can see that both of these are the same, so we can basically write them just once. And these will go together, x squared minus 9. The difference of squares can apply to this because x squared and 9 are both perfect squares, and the operation is subtraction. So we can write them as x plus 3 times the quantity of x minus 3. So now we have x plus 3 times the quantity of x minus 3 times the quantity of 3x plus 5. We set each of these factors equal to 0. X plus 3 equals 0. X minus 3 equals 0. And 3x plus 5 equals 0. And we subtract 3 on both sides, making that x equals to -3. We add 3 for both sides here, which makes it x equals 3. And for this one, we subtract 5 first. Subtract 5 on both sides, and that becomes 3x equals -5. Then we get rid of the 3 by dividing both sides by 3, which makes it x equals
negative 5 over 3. So these are our final answers. To graph this function, we can see that the leading coefficient is positive and the degree is an odd number. That means the arrows will be pointing this way. And we now know our solutions, so we can graph them. And so negative 3 would be here, negative 3, and positive 3 would be here. And negative 5 over 3, if it's hard to visualize, you can kind of like divide negative 5 by 3 and you get negative 1.6 or negative 1.67 maybe. And so we know that negative 1 is here, 0.67, which means it's around like here, between negative 1 and negative 2. And then we can kind of do this and that. We know that this would be kind of right because the graph or the function intersects the x-axis 3 times, which the degree of the equation is 3.
Then, we want to sketch the graph of negative 3x cubed plus 12x squared plus 15x. So what we'll do here is we will pull out a GCF, greatest common factor. We will make it negative 3x squared plus 12x plus 16. Makes this whole problem much more simple. So now we can just put that into the x in the box, and we'll put 16, 32, so 48, negative 48 for the top and 12 for the bottom. So now we need to find two numbers that multiply to 48 and add to 12. And so I found a slight issue with my math just now. Instead of I put 16 instead of 15. It's my mistake. So this would make 45, negative 45 and 12. So we need to find a number that would equal to 12 and then would multiply to negative 45. So those two numbers would be 15 and negative 3. Now we can just put those in. 15x negative 3x squared, 15 and negative 3x. And then from there we just have to put negative 3x and x, and then 1, and then 15, and then from there we can find that our factored form is x, and then inside parentheses x plus 1, and inside another parentheses negative 3x plus 15. And that looks to be like our factored form. And then from there, we just have to we just need to find our zeros. We'll make our little table. And over here, we're going to put our factors. So we have x plus 1, and we have negative 3x plus 15. Negative 3x plus 15 is the only one that really gets you winded. X equals 0 for x equals negative 1 for x plus 1, and then for this one, I'm actually going to do the math for it outside of my head. So the reason why to go through this process, x equals 0 because x, the term has, or the factor has nothing else with it, which means it must equal 0. Now x plus 1, you just have to cancel out. If you make x plus 1 equals 0, you just have to subtract 1 from both sides, and you get x equals negative 1. Whereas negative 3x would equal plus or negative 15. Now that I'll show them. Here's one thing. So with negative 3x plus 15, if we make that equal to 0, we could just subtract 15 from both sides. Then we'll divide 3 on both sides, and we end up getting negative x equals negative 5. Now what we're going to do is we're just going to divide negative 1 out of both sides, and we will end up with x equals 5. So now we have x equals 5. Our multiplicity is both 1, all three are 1, 1, and 1, which means it's all shoot-throughs. So, with our straight edge, I'm going to just refine these lines that I already drew. Make them better, make them thicker. There we go. And then what we're going to do is we're going to find our zeros. 1 0 is in the very middle of the origin. Oh, and one thing that I forgot to do is actually to set x equal to 0. That's surprisingly easy since our GCF is just x, which means it will become 0 and it will multiply out, and all of those will become 0, which means our y-intercept is just 0. Now, that's shown here is 0 plus 1, and then actually we'll put that in parentheses as well, and then negative 3, 0 plus 15, then we have 0, 1, and then 0 plus 15, which becomes 0, 1, 15. Now 0 times 1 just becomes 0 times 15, which just becomes 0, which means our y-intercept equals 0. Which means this one is at 0, 0. Our next 0 is at negative 1. We'll put negative 1 here. And then our next is at x equals 5, which means if we mark up to 5, get right here, we have a negative leading coefficient, and we have a odd degree, which means that we will be going from here to here. Then we'll just go shoot down and up and then down, and that is our very basic, very rough graph. And there you go. That is how you do these two problems.
G of x has a GCF, but to better visualize this, we can rewrite the equation. So negative 3 times 3x's plus the factors of 12. One of the factors of 12 are 3 and 4. So 3 times 4 times 2x's plus, and then the factors of 15 are 3 and 5. So 3 times 5 times 1x. And we can see that they have x and x in common and negative 3 in common. When we take it out, we take out negative 3x. We are left with x squared minus 4x minus 5. Because when we distribute this becomes positive. Negative 3x times negative 4x is plus or positive 12x squared. And this goes the same with here. Negative 3x times negative 5 is positive 15x. Then we can use x box again. So 1 times negative 5 is negative 5. Negative 4 goes here. Two numbers that multiply to be negative 5 but add up to be negative 4 is negative 5, and positive 1. So when we write them inside the box, it's x squared, and negative 5 goes here. Negative 5x, because the variable of this term is x, negative 5x, and 1x, or just x. The greatest common factor is x for this one, and then to get x squared, we have to multiply x by x. And the greatest common factor for this one is negative 5, and then the greatest common factor for this one is positive 1. And we can check that by multiplying again. Negative 5 times 1 is negative 5, x times x is x squared, x times 1 is 1x, and negative 5 times x is negative 5x. Then we write it out as factors, x minus 5 and x plus 1. And then don't forget to write the negative 3x from here. And we set each factor equal to 0. Negative 3x equals 0, x minus 5 equals 0, x plus 1 equals 0. And for this one, we have to divide negative 3 on both sides. And we basically just get 0, because 0 divided by negative 3 is 0. And then here we add 5 on both sides. So we get x equals 5. And for this one, we subtract 1 on both sides. So negative 1, x equals negative 1. So these will be our solutions. X equals 0, x equals 5, and x equals negative 1. To graph this, we can look at this one. We can see that the degree is 3, so it would supposedly, the arrows would be like this. But since the leading coefficient is negative 3, we flip it because the leading coefficient is negative. That means the graph goes this way. And then we can now plot our solutions, or zeros. Our first solution is 0, so 0 would be here. Our second solution is 5, so 1, 2, 3, 4, 5. And our third solution is negative 1, so negative 1. And so connecting those, or graphing the function, you kind of get a graph that looks like this.
Okay, look, I'm honest. Math, I can't lie, I missed you. You and the numbers were the only things that I commit to. I never cheated on the final back when I was with you. But you believed in everything, but Eng, I don't kid you. Eng says I know you changed. I never see you cause you're always busy ditching class. I really wish you had a different way of doing math. I think your math teacher you came from kinda ruined things. It's such an easy class, not much to do but talk and listen. The math is mathing and the students paying all attention, and all your friends telling you answers that you often misunderstand, and take all the images of our Mr. Perfect. I could tell that you've been crying all night, failing all semester, praying for your happy grades, hoping you recover on. This is one I know you hated when you heard it, and it's rich because you know that he deserves to take a shot for it.